Okay, we're going to take a look at expanding monomials and binomials. Now, these two problems that we're going to investigate here, these two types of problems, are taught in very different sections of the mathematics curriculum. However, because they look so similar, they're often confused with each other, and kids start to apply the wrong skills to whichever problem they are doing. So we're going to look at these things in and of themselves. I don't think they're that hard, but then when you're asked to do them, um, they become a little harder because you then got to say, well, which one is it that I'm really doing? So we're going to take a look here, and I'll describe both of these problems and uh, try and key in on the skills involved that you've probably already learned to some extent when you're doing them. So let's see here. We're talking about expanding monomials and binomials. So let's talk about that for just a second. A monomial is a single term expression, which means it's not separated by plus or minus signs. So if we notice, the monomial in these examples is the one on the left, 4xy. Although it has three factors, 4x and y is one term, making it a monomial. And similarly, the one on the right is a binomial. Excuse me, a little smart board problem. The one on the right is a binomial because it, in fact, is two terms. We see the separation of these terms by the plus sign. The first term is 4x, and the second term is y squared. Okay, where it says please expand or multiply as indicated, we're going to apply that right now. The problem on the left, if we notice it's the property involved, it's just an exponents problem. So if we notice here, everything in the parentheses is being squared. It says 4xy all squared. So that just quite simply means we're going to square the 4, square the x, and square the y, which will give us 16x squared y squared. If you want to take a look at that more formally again, when we apply the property, we notice that each one has an exponent of 1, and we can think of this as raising exponents to an exponent, and when we do that, we're going to need to multiply those exponents. So you can think of it as, let me grab some tools here, excuse me. I don't know what that's about. So if I look at the smart pen here, we see that we're going to multiply the 1 times the 2, and the 1 times the 2, and in fact, the 1 times the 2. So in all those circumstances, I'll write the base. So it's 4 to the 1 times 2 is squared, x to the 1 times 2 is squared, y to the 1 times 2 is squared. So that being said, it's just quite easily 16x squared y squared. Okay? Now, the problem on the right is a little bit different. We notice it says the quantity of 4x plus y all squared. Now, I will write this part in red. This is completely wrong. Okay? This is where kids say, oh yeah, if we're just squaring both terms, I would square the left term and the right term, getting 16x squared plus y squared. This is in fact wrong. It seems right when you first look at it, but it's wrong. And let me elaborate as to why. If you notice here, we have two terms. It's not a and b, but I'm just using this as a model. If we have a plus b squared, you have to remember that means it means to multiply the quantity by itself. So if you notice, we have the quantity a plus b times the quantity a plus b. This, in fact, means it's a FOIL problem, where I'll try and draw the arches in while this animation's moving, but it's going to be a times a. Unsuccessful there. So it's a times a times, excuse me, plus a times b plus b times a plus b squared. Okay? So if you notice here, if I were to rewrite this problem correctly, and I'll do that in green, so you know we're a go instead of the red. If I had 4x plus y, quantity, times the quantity 4x plus y, you'd in fact see that when I FOIL that out, I do get the 16x squared to start, but then I get the 4xy, and I get another 4xy, and then I finally get the y squared. So if you notice, these two terms were correct. You need to realize that there's two more terms you get because it's a FOIL problem. And those terms appear in the middle. I'll continue to combine those like terms and get 16x squared plus 8xy plus y squared. That's the answer. Again, it's not just square the left term and square the right term. I, in fact, get a middle term as well. Okay? Now, the good news is everything I'm circling right here is what I will term and deem the long way of doing this. Okay? So let's take a look at doing this a little bit of a shorter way here. Same problem. And if you notice here, I'm going to apply this model to the problem. Okay? It's a shortcut for squaring a binomial. And if you notice, we do have a binomial squared. And it results in 3 terms, which is a perfect square trinomial, the vocabulary for it. And if you notice, I do get the left term squared, and then I'm getting the right term squared as part of the answer. But there's this middle term, which I'm going to say is 2 times the product of the left and right terms. So if we notice the left term is a and the right term is b, its product is ab, and then it's just in fact doubled. So let me do that out now and see what we get here for this problem. I'll clone it, bring it down here, and we'll use that model again. So we see that I'm going to get the left term and square it, which is going to give me, in fact, 16x squared. And in the middle, I'm going to get the left term times the right term, including the sign for the right term, which is positive there, which is, if you notice, 4xy. But then that's going to be times 2. So I just double that. This gives me 8xy. And then the easy part, again, is to take the last term and square it, which gives you positive y squared, which becomes plus y squared. And if you notice, that in fact is the same thing as doing the FOIL problem. And this is a very powerful model to use. And again, you just have to practice the mantra of saying squaring a binomial means you will get the left term squared, 2 times the product of the left and right terms, and the right term squared. Just use the appropriate signs, and it'll be put together as an appropriate expression. So let's continue to practice here, okay? Where it says, there's more examples, please expand or multiply as indicated. And the first thing I want to do here is kind of size up which problem is which. Here's a situation where I will have a monomial and square it. So there's no left squared plus 2 times the left times right plus right squared. That's the trick we saw here. It's for when you're squaring a binomial. This problem here, we are just squaring a monomial. So you don't want to confuse that with what I just showed you in the right example on this slide. Okay. Now if you notice, this is a place where we do have a binomial that's being squared. You will need that algorithm that we just did on the right side of this slide. Okay? Similarly, on this problem, it's a binomial squared. Okay? And in this last problem here, it's a monomial squared. So, let's take a look at this and just get to work. In this first problem, I'll just square each of the factors, which is going to give me 144, a squared, and b to the 6, because the rule, again, of raising an exponent to an exponent is to multiply the exponents. And in this second problem, which is the quantity 2a minus b squared, I'm going to, again, apply this model, which is to square the left term, to the left times the right times 2, and then square the right term. So that is going to give me the left term squared, which will give me 4a squared, because I'll square the 2 and the a. And then I'm going to do the left term times the right term times 2. So that's going to give me a negative 2ab, but I'm going to double it. So I'm going to get negative 4ab. And then I'm going to take the right term, which is negative b, and square it, which becomes a positive b squared. Also, again, noting, if I were to turn that into a FOIL problem, which would mean the quantity 2a minus b times the quantity 2a minus b, I would FOIL it out and get this when I was done. But this is a much better shortcut, again, to use that model. Okay? You just have to practice it a little and you'll become lightning fast with it. Okay, so that being said, I'm going to apply that model again here. So we notice it's x squared squared when I square the left term. That's going to give me x to the 4th. If you wanted to write it in the margin to get a look at it, where it's x squared squared, it would be very obvious it's x to the 4th. And then we get x squared times 6y. But we're going to double that. So we get 6x squared y doubled is 12x squared y. Notice when I double it, the exponents don't change. Okay? And then here, I'm going to take 6y and square it, squaring both terms. I'm going to get 36, excuse me, squaring both factors, I get 36y squared. And that is the answer. Okay, this last one, we're kind of back to easy. It's actually just like the first one. I'm sorry, a little copy-paste kind of problem here. Let me just change the problem here subtly here. I'll call it 5a cubed b squared. Okay? So again, though, it is a monomial squared. There are no add subtract there. It's just one term made of 3 factors. So let's take a look at that. I'm just going to square each factor and get 5 squared is 25. A cubed squared, if you're not sure about it, you could write it in the margin, but you should remember that that rule is very quickly just to multiply the exponents, which is going to give me a to the 6th. And then I'll square the b and get b squared. So again, there's 2 principles here. One is using the properties of exponents on problems like this, that a lot of kids see this with the square, okay, and they start to get a little thrown off when they compare it to problems like this that have the square, okay? But these problems 2 and 3, they're binomials squared. 2 terms separated by a plus or minus sign. 2 terms separated by a plus or minus sign. Okay? So monomial squared is just use the exponents. Binomial squared is again to square the left term, do 2 times the product of the left and right term, and square the right term. So feel free to watch again. Enjoy.